Hello and welcome to our video for our slideshow. On behalf of Evan, Hayden, Jack, and myself, this is our proof of concept for the city of Charlottetown. Our initial thoughts for our project was creating a fire hose nozzle that would essentially reduce the pressure from the fire hydrant to the output of the nozzle. Where the idea came from. The thought process is the water coming out of the nozzle right now is damaging the tree bulbs. We need to reduce the pressure from that to stop the tree bulbs from getting the soil washed away. We decided to not go with this problem because after our meeting with Nick, he had mentioned that this is not really the main issue. What is it? So we have decided to go with a dirt trough that has a liner embedded into it to hold water. The tree bulbs will then be placed inside the trough to continue to get the water they require to survive while waiting to be planted.
So I will now be discussing the setup and implementation of our tree root ball watering system. So in order to start, the city will need to bring in dirt or fill around the fence at the water treatment facility. We are looking to have 3 rows of dirt there that are 100 feet long and 3 feet wide and tall. Then we would need to bring in a backhoe or small excavator. This would be in order to dig out the trough itself. The next step then would be to use the plastic liner and cover the inside of the trough. Using the extra dirt that has been dug to make the trough, we can then pile it onto the sides of the plastic sheet in order to hold that in place. And as previously mentioned, there will be 3 troughs, each holding up to 25 trees, with 75 trees being held in total. And in order to water the system, it can simply be filled using the current setup with water by means of the fire hydrant on site. Although it is recommended by us that the water be sprayed in between the bulbs in order to not wash away the root ball itself. Again, the goal of this system is for the water it holds to supply these young trees with sufficient water to keep them alive until they are later on planted. As for our evidence and calculations, research indicates that young trees need 2 to 5 gallons of water per day per inch of diameter of their trunk. And so in terms of our calculations, we assume the worst, which is 5 gallons per day. And when we met with Nick the first time, we were informed that the rough average diameter of the trees is about 3 inches. And so with a rough calculation there, with 75 trees, that would result in 1,175 gallons of water being absorbed every day total. So in order to hold the 75 trees that are necessary, we will need 3 troughs of 100 feet each. Again, when we met with Nick the first time, he informed us that each bulb is roughly 3 feet, give or take. Some would be larger and some would be smaller. And so 100 feet of our troughs should be sufficient enough to hold 25 trees with adequate space in between each root ball. Each trough has a radius of 3 feet and a maximum water capacity of 2,643.8 gallons. However, we do not want to waterlog the tree bulbs, and so it is recommended that our trough is filled about halfway, which means the water capacity would be 1,321.9 gallons per trough. And so to continue on, assuming now that each trough holds 1,329.9 gallons for 25 trees, and assuming again that the trees drink the 5 gallons per day with a 3-inch trunk diameter, this would result in a loss of 375 gallons per day per trough. And so worst case scenario, we believe that the troughs would have to be refilled once every 3 days. As for water loss, leakage we do not believe should be a major issue here, as the propylene sheet is very comparable to that of a standard pool or pond liner. Over time, over multiple years, this would eventually need to be replaced. However, the plastic should be able to remain in there for the extended future. As long as the trees are placed in and taken out with caution from the trough, we should not have any sort of rips or tears in the liner. And evaporation we don't believe should be a huge issue. It should be quite insufficient because of the large amount of water that is being poured into these troughs. Again, if the troughs were watered every third day, there would be enough water left over in order to account for any evaporation as well.
For this project, there are several potential add-ons. The main one that we think would be beneficial to this project is a PRV, or pressure reducing valve. This will bolt to the fire hydrant in between the hose and the hydrant. It will allow you to adjust the PSI from 30 to 300, giving you a range to make sure that you are not washing away all the dirt off the bulbs, hurting the trees with the hose, or just stripping all of the topsoil nutrients away from the tree. This will also make it easier for the person watering so that they don't have to withstand all the pressure of the fire hose. This add-on has many benefits, but we decided to make it optional because it is a little pricey.
There's a few limitations with our design, not necessarily problematic things, more so how the process will need to be done. So for instance, with watering, if our hose pressure reducer does not work as intended or isn't included, you will need to spray the water from the hose around the bulbs. This is due to the fact that the high pressure will spray the soil off the bulbs. So you can just spray it on the back of the berm, and that will trickle down underneath the roots. And if the reduction is ample and works well, you can just spray the bulbs directly. The tree roots, however, will not be fully submerged in water, but this won't affect the overall absorption because only part of the roots will not be in the water. And the water will need to be sprayed around each root bulb individually because the root bulbs might fill up and block water from flowing throughout the whole trough. So you would need to go down the line spraying each one. There's also limitations with the liner. The pond liner is black, which may affect the water retention due to evaporation. However, this will be a minuscule problem.
The cost breakdown of this project comes to you will need black poly sheets of pond liner, which come in a 24 by 100 foot roll, which each roll is $522, and you will need 2 of those at $1,044. The dirt that will be needed to make this system comes to about 45 yards, which is $2,700. The PRV, or pressure reducing valve, is $3,684, but that is optional. To calculate the price of the dirt, we took the price of 4 yards of dirt from an independent landscaper, took that and calculated how much it would cost to get 45 yards of dirt, which is how we came to $2,700. Now, this would also have to be including the labor to install it from whatever company did it, but those numbers will vary, so we didn't include that in this slide.
Effectiveness and basically the overall efficiency of our trough design. So the trough will be filled 2 feet high, which is enough to submerge the root bulbs over halfway up their overall size, being 3 feet-ish. The whole trough will be capable of holding 10,570 gallons of water throughout the whole thing, plus some that will be absorbed in the roots while filling it up. The plants would need to be watered twice weekly, preferably every Tuesday and Friday. The water will only last in the trough 3 days, so to keep the roots fully submerged in the trough, it will need to be watered at least every 3 days. The watering process overall will take an hour to an hour and a half every week to go up and down the line watering, so it won't be that much of a hassle for a worker to go out there.